Hello and welcome. I am Dr. Pauline Fu. In this video, I will talk about contingency tables and association. These refer to two variables. At the end of this lecture, you would be able to compute the marginal distribution of a variable, use conditional distribution to identify association among categorical data, explain Simpson's paradox. I will use an example to illustrate contingency table. So this example is about a class at a community college. I actually did a research project 10 years ago. I want to see if there's a significant difference among different teaching methods, such as face-to-face in classroom, that is the traditional teaching method. The second one is the fully online courses. And the third one is hybrid. Part of the course is taught online, part of the course is taught by face-to-face. So this project is about to compare student academic achievement among three different teaching methods. We want to count how many students get A in traditional classroom, how many students get A in online classroom, how many students get A in hybrid classroom, etc. So we also count how many students get B, C, D, and F. Okay, so this is the data about the project. Compare student academic achievement in terms of their final grade, letter grade, A, B, C, D, F, across three different methods. So this table is a contingency table or two-way table because it relates to two categorical data. One categorical data is teaching method, traditional teaching method, online teaching method, hybrid teaching method. The other categorical variable, final letter grade, A, B, C, D, F. Okay. So this is a contingency table. Oops. And once we get this contingency table, what can we do with the contingency table? We can determine the relative frequency marginal distribution, okay, for course grade and delivery method. So how do we calculate relative frequency marginal distribution? I will use Excel to explain. So this is the data I just copied from the PowerPoint slide into Excel. When you have this contingency table, first you figure out what is the total number of students in traditional classroom. So you do sum. All of these students are total number of students in traditional classroom. Okay. And you do the same thing for how many students in online class, how many students in hybrid class. That is the column total for different teaching methods. Okay, so that is the total. And then you calculate another total. How many students get letter A across three different sections? So you type in equal sum, add this number, And you do the same thing to calculate how many total students get letter B, C, D, and F, and how many grant total. What is the total number of students? On the project. Okay. So this one looks like G4. This one not right because okay, let's redo it. You want to add all these three numbers. Okay, and then do the same for other letters. So the total number of students in this project, 743. Okay. So once you have this number, and then you use relative frequency marginal distribution. So you use this number, 99, divided by this total number. Okay. That's how you get 0.133 over here. 0.133 is the result of using the raw total, 99, divided by the grand total, here, 743. Okay, so I'm going to copy this Excel later on. So you do the same for other cells. So everybody divided by a grand total. That's why I need to change this total to absolute cell reference, $I, $9, so that when I copy down the formula, I can copy down the formula. See, this number you get is here, 0.233, okay? How did you get 0.233 again? So you use the second raw total, 173, divided by grand total, 743. And do the same thing for the relative frequency of different teaching methods. Okay, so I'm going to put the result here. So use this number, 237, divided by the grand total. Again, I change the grand total to absolute cell reference, $I, $9, so that I can copy down the formula. See, you get 0.3189. See here, 0.3189. And you copy down the formula. See, the second number, 0.34. 0.34. Okay. So I'll just copy this so that we have a reference later on. Okay. So that is how do you get this number? So I'm going to explain how do you get 0.319. You use 237 divided by grand total, 743. Okay. So this result is relative frequency marginal distributions. Okay. Based on this, what can we say from these marginal distributions? You can say for those students who get later, yeah, that is the relative distributions. Okay. Next, we are going to take a look at conditional distribution to identify association among categorical data. And this example, we are going to use the same data set. This is original data. And our task is to find conditional distribution. Conditional distribution means given some condition, okay? So for example, if given the teaching method is traditional, how much percentage of students get letter A? How much percentage of students get letter B? Okay, that is the condition. Under the condition of traditional, you figure out the percentage. The result is 15.2% in traditional classroom get A, 21.9% in traditional classroom get B. So now, how do we get this 0.15%, 21%? Again, we are going to use Excel to illustrate the process, okay? So I'm going to delete this, redo it. Delete this to see the try to fit two windows in one screen. Okay, so traditional, the percentage of students get letter A in traditional classroom equal to 36 divided by total people in traditional classroom is 237. Again, you want to copy down the formula, you have to use the absolute cell reference, $F, $9, okay, so that you can copy down the formula. See, this number you get exactly the same as here. Okay, and then you do the same thing for online class. There's an easy way to do it. If you can just modify this formula to have a mixed reference. So the mixed reference means you want to fix row 9 because you want to copy down the formula to the right. Okay? You want to fix row 9. This formula, you just need to keep the $sign in front of 9, delete $sign in front of F, so that it becomes mixed reference. No, I will keep the original format. Maybe I will just, on safe side, I'll redo it. So how many students in online classroom get letter A? Use this number divided by total number of students in online class. Okay, so change to absolute cell reference and copy down the formula. Okay, so you get this second column number here. So last one, let's calculate hybrid. How many students, how much percentage of students in hybrid get letter A equal to 24 divided by total number of students in hybrid. Okay. Change to mixed reference. No, absolute reference. Change to absolute reference and copy down the formula. See, you get this third column. So this is how do you get conditional distribution. So I'm going to just add a note. How did you get this 0.152? Okay, you use 36 divided by how many total students in traditional classroom? 237. 237. Okay. Another example, how do you get, for example, 0.095? You use this 24 divided by total students in hybrid class. That is 252. Okay. And once you get this conditional distribution, you can see the percentage of students get letter B and C. are higher than the percentage of students in traditional classroom and in online class. Okay, so the hybrid maybe is a better choice in terms of students' academic achievement. So we did this using the conditional distribution to identify association among categorical data. We are saying the hybrid class have a higher percentage of students get letter B and C and have less failure rate, see? Okay, less failure rate compared to traditional classroom and online class. Next, let's use the graph to visually represent the conditional distribution. Conditional distribution. Okay. So to produce a graph, you just need to go to Excel, highlight all this data, conditional distribution, and then go to insert, bar chart, okay, or column chart. See, you get this graph. Okay, you get this graph. Okay. Okay, exactly the same as this graph here. All right. Let's take a look at another example. This contingency table shows the survival status and the demographics of passengers on the Titanic. Titanic, we know that, okay? So for men, how many survived? 334. How many died for men? 1,360. Okay. For women, 318 survived. 104 died. Similarly for boys and girls. Okay. And the question asks you to draw a conditional bar graph of survival status by demographic characteristics. To draw conditional bar graph. Remember, the bar graph is based on the table. So we have to create a table showing the conditional distribution table. Okay. So again, we are going to do this using Excel. So this is my this is the original data. Okay, original data. Because the question asks you for survival status, so we need to create total number of men, total number of women, total number of boys, and total number of girls. So we just use sum. These two numbers are together, and then copy down the formula. Okay, so that is the total number of categories, different categories. And next, we are going to create a conditional distribution. Okay, so for survival, how much percentage? So survival is 332 divided by this number here. Okay, so this time I will do differently. So this number I will change to mixed reference. So the row is fixed. So I will fix row 29. Okay, because I want to copy the formula later on. So I just changed to F$29. And then I can freely copy to the right and then copy down. Okay, that's the beauty of using mixed reference. You do not to repeat yourself many times. Just type in the formula once, then copy to the right, copy down. Okay. So anyway, this is the conditional distribution. So we are going to create a bar chart based on this conditional distribution. So you highlight this data, okay. Highlight the data, and then you go to Insert, Bar Chart, and you get this graph. And you get this graph. So I'm just going to copy this data so that I can make annotation. Okay. Here. So again, how do I get this 0.19? Okay, how do I get this one? I use 334 divided by 1,669. So I get this number. Okay. So how do I get this number? I use 104 divided by 244. 104 divided by 422. So that is the conditional distribution. Okay. And also this graph shows using the color, the purple represents died. Okay. This green represents survived. You have a virtual representation. So far we did a marginal distribution table. We did a conditional distribution table as well as the bar graph. Next, we'll explain Simpson's paradox. Again, we'll take an example. Insulin dependent, also called type 1 diabetes, is a disease that results in the permanent destruction of insulin producing beta cells of the pancreas. Type 1 diabetes is lesser unless treatment with insulin injections replaces the missing hormone. Individuals with insulin independence, that is type 2 diabetes, can produce insulin internally. The data shown in the table represent the survival status of 902 patients with diabetes by type over a 5-year period. So we have two types of diabetes, type 1, type 2. How many survived for type 1? 253. How many survived for type 2? 326. And this 105 died from type 1. 218 died from type 2. And how many total patients? 902. Okay, so based on this table, we can create a raw total. Add these two numbers together, you get this number. Okay, and add these two numbers together, you get this number. Okay, and then we can calculate, for example, the proportion of patients with type 1 who died was 105 divided by 358. That is 0.29. Okay, this is the proportion of patients died from type 1. Similarly, the proportion of patients died from type 2. We use 218 divided by 544, and we get 0.4. Based on this calculation, so if you compare, this is the proportion died from type 1, 0.29, proportion died from type 2, 0.4. Based on this, it seems that type 1 is more lethal than type 2. Okay, so people died more from type 2 than from type 1. But is this true? So, to investigate this conclusion, we divide the data based on their age. Okay. So if people is younger than 40 years old or older than 40 years old, and we collected those data again. And then we figure out the totals, row total, column total. And then if we consider the age factor and we redo the proportion, okay? So of the diabetes 40 years age or younger, the proportion of those died with type 1 error is 1/130, that is 0.008. And the proportion of those with type 2 diabetes is 0/15. Okay. And then we look at people over 40 years age, the proportion of those died with type 1 is, okay, over 40 is, see, this is over 40, so died from type 1, 104 divided by 228, the result is 0.456. And for those type 2 over 40 years old, people died from 218 divided by 529, result 0.412. So if you compare people died from type 1 over 40 years old with people died from type 1 over 40 years old, you see the proportion of people died from type 1 is more than the proportion died from type 2 for people over 40 years old. So this conclusion contradicts the conclusion we get here. This conclusion, we say, the proportion of people who died from type 1 lower than proportion of people who died with type 2. So type 1 lower type 2. And here, when we consider the age factor, we are saying people die with type 2 are higher than people die with type 1. The proportion of people die with type 1 is higher than the proportion die with type 2. So there are two different conclusions. Okay? So from these two different conclusions, what can we say? We can see the lucky variable age is taking effect, because the lucky variable age make us believe type 2 is more dangerous. Okay, so when you draw a conclusion for any research project, you may want to consider the lucky variable because it will distort your conclusion. So what is the Simpson paradox? It describes a situation in which an association between two variables inverts or goes away when a third variable is introduced to the analysis. In this case, this third variable is age. When you introduce age variable, you get a completely different conclusion. Oh. In summary, what we did in this video, we did 3 things. First, we did marginal distribution table. Second, we did conditional distribution table and use this conditional distribution table to identify association. Last one, we explain Simpson's paradox. Oops. That's all for this lecture. There are strong winds, higher winds. Thank you so much for watching. See you next time. Enjoy the beautiful weather.